differential GPS. So, like I said, why can't you use your mobile phones or handheld GPS devices for surveying? The reason was in normal GPS operation, errors are huge, and those sort of errors, I'm talking about meters of errors, are not feasible when we talk about surveying. So there has to be some methods by which we can reduce those errors so that a GPS device can be used for surveying purpose. And one way to do it is by using a device which is called as a differential GPS. And what it does is that instead of using just one GPS device, it uses two GPS receivers. So basically what you do is you place one GPS receiver at a point whose location is known, and the other GPS device or other GPS receiver is taken to points for which you want to find out their coordinates or their location. So once you do it, um, what happens is that both the receivers do not have a lot of distance between them. It's usually less than 1 kilometer. So if that's the condition, at any instant of time, both the receivers correspond to the same satellites. So both the receivers will face the same errors. Errors from the clock bias, from the atmospheric refraction, not the errors such as multipath interference. Those errors can be different for both the receivers. But if you negate those errors, if you take care of those errors because those are in your own capacity, the other errors, which are universal in a sense for both the receivers, would be same. So for one receiver which is on a location whose coordinates are known, the correct coordinates are known, you can calculate the amount of error and the amount of correction. And the same correction can then be applied to the other receiver, which is located at a point of unknown coordinates. So in a way, you can apply correction to all the other readings. So this is how a differential GPS works, and this is how you can really reduce the amount of error. Now the question arises that how do you find out um, the correct location of one point? So that can be done by other methods, by the conventional surveying methods, through which you can find out the accurate coordinates of one point. Um, if you remember what a benchmark was a permanent benchmark was. So that is how you can identify the correct coordinates of one point and then work from there. Other ways, अगर आपने GPS ही use करना, what you can do is you can place the GPS at that point for extended periods of time and take extended readings. इससे क्या होता है, if you place it there for number of hours, a lot of errors get nullified because the atmosphere changes during that time, the geometry of the satellite changes, different satellites come into position, the clock errors change, and if you take a number of readings over extended period of time, then you have a data set, and then using that data set by using the methods of probability that we used, we can find out the accurate coordinates of one point. And once you have those, uske baad, the process gets very simple. So this is where it comes into real benefits. So if you see this picture over here at the bottom left, you have this control center. Obviously, in there you have a GPS device whose coordinates are accurately known, and from there, you can apply the same correction to the GPS present in a car, in a ship, or an airplane. Using those corrections, you can correctly align the direction of travel of an airplane. And on the right picture, this is how it basically works. The same satellites are in connection with a reference station, and the same satellites are in transmission with your moving station. So in GPS terms, we call the location whose coordinates are known as the base station, and the GPS, which is in motion, which is going to places whose coordinates are not known, we call that as rover. So base station and rover. Now I would be referring to these two in these terms. So one method was differential GPS. Another method is relative positioning. इसमें क्या है कि usually what you need is you don't need the coordinates. आपको क्या चाहिए? You need relative distances between 2 points. जिस तरह if you're working in a closed reverse, उसमें even if you don't have the angles from the north, if you have relative angles of different points between each other, that's fine. जो आपके localized projects हैं, उसमें you don't need to work with the bearings from the north or the coordinates. उसमें if you have relative distances between points, if you have relative angles, that's enough. So that is where this process comes in of relative positioning. So in this method, what we do is we take one location as a 0, 0 coordinate, let's say, yeah, it has the distance of 0, angle of 0, और वहां से we find out the relative positions of other points. और इसमें कैसे होता है that you use two or more receivers, one receiver at one point, other receiver at the other point, or you get different linear combinations. And how do you do that? You have the coordinates coming in terms of latitude, longitude, usko you put in equations, and the equations give you the x coordinates, y coordinates, and the distance between. So you have different linear equations. Another thing you can do is you can measure one distance. So for example, you can measure the distance physically between point A and point B. And then using those equations, you can see here what is the distance that these equations are giving me. And then you can replace the accurate distance value, and then by back calculations, you can apply corrections to the coordinates value. And then in this way, you can find out the actual corrections. इसमें we have three different methods. We have single differencing, double differencing, and um, triple differencing. So in this method, what we do is in single differencing, we locate two receivers, and then we take the readings from a single satellite at one instant of time. In double differencing, we take more than one satellite, and at any instant of time, we take different readings. So what we're doing is we're taking data from different satellites, and that is increasing the number of equations that we have. In triple differencing, we do the same thing, but we do it at different instances of time. And remember, go back to the errors in GPS surveying. Usme, there were errors such as the geometry of the satellites is not good, or there are clock biases. So once you take readings at different times, वो वाले जो errors हैं, they become nullified because different satellites come into position, the geometry changes over time, so those sort of errors get nullified. So to sum it up, what are the factors that affect the accuracy of satellite surveying or once you use GPS? So there are a number of points. One is accuracy of the reference stations to which the survey will be tied. So that means जो हमने बात की है that there should be one base station. And the first step is to find out the accurate coordinates of the base station. If there's error in doing that, that means उसके बाद जो भी आप काम करोगे, that will be erroneous. It's same as finding out a baseline. So if you remember, if you go back to the topic of baseline and go back to the topic of tape measurement, उसमें we apply a number of corrections to that measurement. क्योंकि that baseline will help you to find out different readings later on. Triangulation में भी आपने पढ़ा होगा that one line is your baseline. Similarly, over here, the base station is to which all the corrections are tied to. If you find out correct coordinates of the base station, all your further corrections will be accurate. Number two is number of satellites visible during the survey. More the number of satellites, the better it is. That is why they say here, if you're working with the American system, uski maximum satellites available would be 4 to 6. But if you combine it with the Russian system, the number of satellites visible would be around 10 to 12. So that would mean that the total accuracy of your survey increases. Geometry of the satellites during the observation sessions. So you have the weak geometry and the strong geometry. And since you've studied the triangulation topic, you can link it to that as well. और इसको पूरा करने के लिए the solution is that you perform the survey for extended period of time or at different time instances. Fourth, atmospheric conditions during the observations. We studied if you perform the survey during the night time, it gets more accurate. But if you want to perform it during the daytime, then again you have to increase the amount of time for which you perform the survey. Lengths of observation sessions. The more the length of the session, the more the duration, the more accurate the survey. It doesn't mean that जो हमने बात शुरू की थी that GPS is a very quick procedure. It doesn't mean कि वो वाली बात आपकी nullify हो जाती है. If you accurately find out the coordinates of the base station, एक दफा वो काम कर लो, the time for survey for other points decreases क्योंकि base station के ऊपर आपके पास you will get correct accurate corrections जो कि आप apply कर सकते हो to other stations. So there's a question that why the strength of figure is directly related to error and inversely to accuracy. So in a sense, the weaker the geometry, that means the satellites are very close to each other. So जो भी आपके atmospheric conditions की वजह से errors आ रहे हैं, they become multiplied. And the far apart they are, the satellites have different conditions, the signals have different conditions, your other factors get take care of, such as multipath interference. That is why it's better that the satellites are at a wide apart angle. Usually 60 degrees का angle होता है. And that's better. जो आपने triangulation में भी इसका पढ़ा हुआ है, उसमें भी यही है कि जो acute and obtuse geometries वो weak होती हैं. And once you have a geometry that is between 30 to 60 degrees, I think that's a strong geometry. उसमें trigonometric ratios जो आप use करते हो, they also minimize the errors. अच्छा उसके बाद है number and nature of obstructions at the proposed receiver stations. That links back to the multipath interference. That is the reason. The clear the trajectory is, the better. Number of redundant observations taken in the survey. I discussed it. Um, Redundant number of satellites and redundant number of observations. Both will help you. जो आपका टॉपिक था theory of errors and weights, उसमें हमने ये किया था that the more your data set is, the bigger the data set is, उसके ऊपर ज्यादा आप statistical techniques use कर सकते हो to find out the errors. अच्छा, now that we have studied कि what are the factors on which the accuracy depends, उसके बाद they have classified the survey into 4 different forms. And these 4 different forms of survey take care of those issues. And what it does is कि you say कि यार, okay, I want to carry out baseline surveying. So if you want to do that, that means you need very accurate work. And based on that, you can select from these 4 techniques that we're going to study now, which one to choose. In the other case, you say, "Yaar, I'm doing reconnaissance survey or preliminary survey." In that, you don't want very highest level of accuracy. उस case में you would be more interested in speed of the survey. उस case में you can select care of these methods, which one can I use. So the first method is static relative positioning, and keep in mind 2 factors, accuracy and speediness. In these 4 methods, the two will interchange. The first method is called as static relative positioning. As evident from the name, this process would be more accurate, but it would take the most amount of time. इसमें क्या होता है? You need minimum 2 receivers, A and B. So let's say I have 2 points A and B. One receiver is at A and the other receiver is at B. A is my base station and B is a station whose coordinates I want to find out. I have other stations as well, C, D, and E. Let's say I want to come up with the correct coordinates of these 5 points, and A is my base station. So what I would do is I would place one receiver at A and one receiver at B. If I have more number of receivers, at the same time, I can place other receivers at C, D, and E. And what I would do is I would uh, take readings over extended period of time. So the process says that one receiver is placed at the base station, the other receiver is placed as the unknown stations, and simultaneous observations are made from all stations for a time period of an hour or more. So for extended period of time. And what will happen? Your accuracy will keep on increasing. So what we will do is place one receiver at A, call it as base, and other receivers at B, C, D, and E. Keep them as it is for 1 hour, take the readings. You get the corrections from the point A, apply the corrections to all the other points. Now you know the correct coordinates of all other points. Now what you would do is you would take B as the base station, call it as the base station, and repeat the same procedure. All the other receivers at other points, place them for 1 hour, do the same thing. Uske baad make C as the base station. So what we are doing is one by one, we are making each station as the base station, repeating the procedure. And in a sense, what we're doing is we are increasing the amount of time of readings. We are increasing the amount of readings. We are taking redundant readings. So what we will get in the end is very accurate readings, very accurate work, but the time duration is a lot. So that's a trade-off. So this process is static relative positioning used when you need very accurate work for the baseline work, let's say, and you have a lot of time. उसके बाद हम आ जाते हैं रैपिड स्टैटिक रिलेटिव पोजीशन एज द नेम सजेस्ट इसमें क्या होगा it would be quicker than the previous method but it would be a little bit less accurate than the previous method. So इसमें what we're doing is that it's similar to the static serving that we did, except that one receiver always remains on the control station while the others are moved progressively from one point to the next and an observing session is conducted. और इसमें the sessions are lesser for a lesser amount of time than the static method. So इसमें हम लोग क्या करेंगे? Again, take the same example. We take 5 points A, B, C, D, and E, and we make the A station as the base station, place one receiver there, and then place other receivers at all the other points, take one reading over some time lesser than 1 hour, and apply the corrections that you get from the base station to other points. And you just do it once. So this process is quicker than rapid static, but still you have to remain at each station for a longer period of time. It's not that quick. उसके बाद the name changes to pseudo kinematic survey. The next is kinematic, which is the quickest. This one is called as pseudo kinematic. So this is quicker than the previous two. As we go down, the processes become less accurate but quicker. इसमें हम लोग क्या करें? This procedure is also known as intermittent or reoccupation method. So the base receiver always stays on the control station. So if I can redraw the same example that we've been doing, we take 5 stations. So it says that the base receiver always stays on a control station. So let's say if A is the base, one receiver would always remain over here. And the other receivers, which are called as rover, go to each point of unknown position and two very short observation sessions, 5 minutes each in duration, are conducted. And the time lapse between the first session at a station and the repeat session should be about an hour. So what we're doing is we've placed one receiver at the base A, the other receiver is placed, let's say at B. Let's say we're working with only two receivers at the moment. The other one is placed at B. You place it there for 5 minutes, take a reading, then take the receiver to point C, again do it for 5 minutes, then to D, and then to E. After that, you wait for 1 hour and then you repeat the procedure again. इसमें फायदा क्या है? That the observation time is only 5 minutes as compared to 50 minutes or an hour as we discussed previously. लेकिन they say you repeat the cycle twice. Why repeat the cycle twice? To take redundant readings. but the sessions are very shorter as compared to the previous methods. Finally, the last method is kinematic survey. As the name implies, during kinematic surveys, one receiver, the rover, can be in continuous motion. This is the most productive of the survey methods, but is also least accurate. So in this method, what we do is one receiver is placed at the base station and the other receiver is always in motion. You don't have to wait for 5 minutes even. This picture maybe what they've shown is that it's attached to an actual rover and you keep on moving and at the location where you want to find out the coordinate, you just note down the reading instantly. So usually you use this method when you want to perform less accurate survey, but time is of utmost importance. So आपका जो surveying आप कर रहे हो, for example, over here they're doing it for a coast. So they're trying to find out कि let's say the tides जो आती हैं, waves जो आती हैं, what is the maximum distance that they reach. So आपने उसकी एक boundary बनानी है, उसके coordinates find करने. So that means you have to cover a lot of distance. And if you keep, if you take an interval of, let's say we take a reading at every 100 meters, the number of readings are a lot. And if you take any of the previous methods, that means the survey would be extended to large amounts of time. Lekin if you're doing kinematic, that means you don't even have to stop. After every 100 meters of distance, you just note down the reading instantly. So this process is very quick. So this is an actual picture of a rover. अभी किसी ने क्वेश्चन भी किया था, what is the difference between the GPS in our phones and the GPS devices that are very accurate? So as you can see from the picture, this is exclusive device used for GPS surveying. आपका जो phone है, it has a lot of functions and one of the function is GPS. उसमें जो GPS है वो receiver है that is um, of a very least accuracy. Uh, ये वाला जो है, obviously the receiver is very strong, the signal strength is very strong, it can connect with different satellites very quickly, so all of those things. नीचे इन्होंने टेबल में भी बताया हुआ है कि for what method of survey, uh, what amounts of time do you have to stay there. It also depends on how far away you are from the base station and all of those things. If you're using single frequency or double frequency, remember in the beginning we studied they have two frequencies, one is commercial and one is for their exclusive use. So if, for instance, you have both the frequencies, the signal is stronger, then the amount of time required to take the reading decreases. Okay, so we were discussing kinematic survey and we discussed that it's suitable when time constraint is more and accuracy is not that much of a concern. Obviously, accuracy here because we're using a rover, it would be around, let's say, 1 to 5 centimeters away from the real location or the real coordinates, but it's very quick for which you can perform it. Isme we have another thing which is called as real-time kinematics, and in that what we do is that um, but before that let me try to explain the point that I am trying to come to. Yeah, so the main difference between static and kinematic serving techniques is the length of time per session. Establishment of control point using a static surveying method requires much longer sessions but much accurate survey as well. Kinematic surveys generally follow two forms of data collection. In true kinematic mode, data is collected at a specific rate. This method is useful for collecting points along an alignment or grade elevations, something that I just discussed, जो coastal example अभी हमने discuss की है. An alternative to true kinematic mode is to stop for several epochs of data, for several instants of time, it means. This method known as semi-kinematic or stop and go mode, for ये pseudo kinematic की बात कर रहे हैं, for mapping and construction surveys where increased accuracy is desired for a specific feature. अगर आपको accuracy ज़्यादा चाहिए, you stop at the instant, you give it more time, it will give you more accurate survey. In post-process kinematic survey, the collected data are stored on the survey controller or receiver until the field work is completed. and the data is then processed in the office using same software and processing techniques. So इसमें क्या है that you go to the field, it's like you perform compass traversing. You take all the data and then you go back to your class and or your own places, and then you perform the correction work. This would be called as post-process kinematic survey. Real-time kinematic में क्या हो रहा है? That there is a communication between the base station and the rover. So let's say base station हम लोग कहते हैं कि in the civil department, inside a receiver is installed and that we call as a base station. And you're working somewhere, let's say near an XE. And whatever readings you're taking over there, if instantly you communicate it to the person at the base station, so what he would do is he would simultaneously apply all the corrections and do the processing and computations at the same time. So this is called as real-time kinematics, when there is a communication between the rover and the base station. Otherwise, you can collect the data, do it at a later time. लेकिन अक्सर ये होता है कि once there is real-time communication, उसमें you can judge. For example, preliminary survey हो रहा है या reconnaissance survey हो रहा है, उसमें you can give instructions. Here now you move to this point, to this point. This point is giving us better results. So it's better to place the base station over here. इस तरह की चीजें communicate हो सकती हैं. So if you want to summarize whatever we've discussed, अगर आपने if you want to use पहली बात तो ये if you want to use GPS surveying for whatever task you want to do, or if you want to go for the conventional methods of theodolite है या उसमें वो है आपके leveling techniques हैं उन पे जाना है या GPS पे जाना है. But if you have decided for the GPS, so how do you plan it? So first thing is, what is the accuracy that is required? So if you want more accuracy, which methods to use? If you want more speed, which methods to use? That should be clear. The other one is the consideration is selection of the stations. So you have to be assured that there is no obstructions. Canopy instructions क्या होती हैं कि you've taken a station above which you have a tree or horizon में you have tall buildings. So what would happen? There won't be direct link between you and the satellite. Usme, the instructions is that you take care of the mask angle. If you see this figure over here at the bottom, जहाँ पे observer है, from his horizon, they have communicated the mask angle. So वो कहते हैं कि जो mask angle है, which is usually 10 to 20 degrees, इस horizon में आपकी obstructions यहाँ तक होनी चाहिए, इससे ऊपर नहीं होनी चाहिए. So over there, because you will be transferring data with the satellites, and if you have obstructions over you, that means your readings would be less accurate. So इसका मतलब ये है कि अगर आप घर में बैठ के if you're using a GPS, it would be lesser, the accuracy would be least, and if you go out, take care of the mask angle, then the accuracy would be more. And then selecting the appropriate survey method. So if you want high accuracy involving baselines, you use the static methods. If you want more speed, use the pseudo kinematic or kinematic method. And if you want mixture of both speed and accuracy, so in methods को combine करके you can use either one. जहाँ पे आपको accuracy चाहिए वहाँ पे कोई और method use कर लो. कुछ locations होती हैं जहाँ पे accuracy is not that important. Over there you switch to the kinematic methods. But the thing is you should be aware of all these methods and why they exist. उसके बाद है for navigation purposes, kinematic methods are used. Obviously, navigation में you don't need pinpoint accuracy. उसमें आपका मोबाइल भी काम कर जाता है. Kinematic methods are good for that. Because of variability in requirements and restrictions of survey, the selection of appropriate survey method is dependent on number one, desired level of accuracy, number two, intended use of the survey, type of equipment available for survey. If your equipment is good, then it means the amount of time you have to spend at a station can decrease. Size of the survey. The bigger the size, अगर आप static method करने बैठ गए, that would take forever. If the size of survey is more, you switch to more kinematic methods. Canopy and other local conditions for the survey. If there are a lot of obstructions, it's better not to use GPS altogether. Available software for processing the data. Because the GPS gives you the coordinates in terms of latitudes and longitudes, you need appropriate software to process the data. You can do it manually, it will take a lot of time. तो ये कुछ चीजें हैं that you have to take care of. उसके बाद फील्ड रिकॉनेसेंस जो इनिशियल सर्वे का आपका सेटअप होता है बिफोर यू गो टू द फील्ड टू परफॉर्म द रियल सर्वे you have field reconnaissance. उसमें there are things that you have to take care of. Once the existing nearby control points and new stations have been located on paper, a reconnaissance trip to the field should be undertaken to check the selected observation sites for overhead obstructions, reflecting surfaces, nearby electrical installations, other problems. So it's better कि यार before you choose a GPS method, especially when the size of survey is more, you log into Google Earth, you take a satellite image, and you see कि वहाँ पे obstructions किस type की हैं, and then using the Google Earth software, or let's say आपने अपनी photography कर ली है वहाँ की from the top horizon आपने सारा देख लिया है, using that you select the points which would be ideal for the GPS surveying, and then you go to those points and take the readings there. So it's better you first perform the reconnaissance survey and locate the points जहां जाके आप readings लोगे so that those points become your base points. Construction में ये कहाँ use हो रहा है? GPS surveying today has taken over the conventional methods. It's really quick. Um, हमारे जो गवर्नमेंट इंस्टीट्यूट्स हैं वो भी इस पे अब शिफ्ट हो रहे हैं. अगर ग्लोबली मैं आपको इसकी एक बात बताऊं, लेआउट सर्वे होते हैं ना, आपने एक बिल्डिंग लेआउट किया था हम लोगों ने, उसमें आपने क्या किया था, यू सेट आउट द आउटलाइन फॉर अ बिल्डिंग. Machines can be controlled using the GPS. So let's say आपने excavation करनी है, that excavation has to be around a particular location, a particular direction. The machines can be linked with the GPS and the machine can work directly on the coordinates input into that machine. इसी तरह से आपके topographic surveys हैं. One way is to use the combination of theodolite and the leveling instrument, and it will take a lot of time. आपने contouring वाला भी method पढ़ा हुआ है. If you use GPS, that method can be improved in speed by a lot. Um, yeah, so these are some methods. I'm going to end the meeting because the time is going to end. So you can rejoin and then I'll switch to your questions and answers.